a single userid label exploded Prometheus memory to 24 GB, crashing a 16 GB pod. Here's exactly why and how to stop it. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Kubernetes monitoring Prometheus. Prometheus is an open-source monitoring system that scrapes metrics from HTTP endpoints. In Kubernetes, it uses service discovery to find pods dynamically, stores the data in a time series database, and fires alerts based on rules. Prometheus pulls metrics from targets at configured intervals. It discovers pods by querying the Kubernetes API. Pods opt in with annotations like Prometheus IO scrape, true, relabeling filters and attaches labels before scraping. Prometheus has 4 core metric types. Counters track totals, gauges measure current values, histograms precompute latency buckets, and summaries calculate quantals on the client side. The Prometheus Operator manages the monitoring stack via custom resource definitions. A Prometheus CR defines the instance. ServiceMonitors declare scrape targets, Prometheus rules contain alerts, and Alertmanager handles notifications. Here's a minimal Prometheus CR and a service monitor. The Prometheus CR specifies resource limits and a label selector for ServiceMonitors. The ServiceMonitor selects services with matching labels and defines the scrape endpoint. Prometheus discovers pods using Kubernetes SD configs. Relabeling lets you filter which pods to scrape, rewrite the metrics path, and attach Kubernetes metadata as labels. This is the core scrape configuration for pod discovery. It keeps only pods with the scrape annotation, rewrites the metrics path and port from annotations, and attaches namespace, pod name, and app labels. It also drops targets running on host network. When using the operator, you can define scrape targets with ServiceMonitor or ScrapeConfig. ServiceMonitor is simpler. It targets a service, and the operator handles pod IPs. ScrapeConfig gives you full Prometheus config syntax for complex scenarios. Here are both CRDs side by side. The ServiceMonitor selects a service by label and defines an endpoint. The ScrapeConfig uses pod-level discovery with custom relabeling, giving you full control over the scrape configuration. To monitor application-level metrics, you instrument your code using Prometheus client libraries. You define metrics like request counts and latency histograms, then expose them on a metrics endpoint for Prometheus to scrape. This Go code defines 4 metrics: a counter for total requests, a histogram for request duration, and 2 gauges for in-flight requests and queue depth. Notice the label sets are bounded: method, endpoint, status code, no high cardinality values. The instrumented handler wraps the actual logic. It increments the in-flight gauge, records duration in the histogram, and increments the request counter with method, endpoint, and status code labels. The status capturing writer captures the response status code. The main function sets up the payment handler, a background coroutine to update queue depth, and 2 HTTP servers, one for the application on port 8080 and one for metrics on port 9091. Prometheus scrapes the metrics endpoint. Recording rules precompute expensive queries into new time series, reducing query load. Alerts should be based on burn rates, not raw thresholds, to reduce noise. Both are defined in Prometheus rule custom resources. This Prometheus rule defines 3 recording rules: request rate, error ratio, and P99 latency. They follow the naming convention level, metric, operations, and are evaluated every minute. These alert rules use the pre-computed recording rules. The error burn rate alert fires when the error ratio exceeds a threshold that indicates we're burning through our error budget. The latency alert and queue consumer dead alert are also defined. Alertmanager receives alerts from Prometheus, deduplicates them, groups them by labels, and routes them to notification channels like PagerDuty or Slack. Inhibition rules prevent alert storms by suppressing lower severity alerts when critical ones are firing. This Alertmanager configuration routes critical alerts to PagerDuty with a short group wait, warning alerts to Slack, and team-specific alerts to their own channel. Inhibition rules suppress warnings when a critical alert for the same service is firing. PromQL is the query language for Prometheus. Key patterns: rate for counters, gauge for raw values, histogram quantile for latency percentiles, and top to find high cardinality metrics. Here are essential PromQL queries for Kubernetes monitoring: infrastructure metrics, application metrics, self-monitoring, and cardinality detection. Use recording rules for queries you run frequently. Prometheus TSDB stores data in 2-hour blocks. The head block is in memory and receives all new samples. Every 2 hours, it's compacted to disk. Memory usage is directly proportional to the number of active time series. This Prometheus CR configures 15-day retention, a 50 GB size limit, and a 100 GB PVC. Resource requests are set based on expected series count. External labels identify the source cluster, and a Thanos sidecar is configured for long-term storage. This is the same issue we highlighted at the start. Here's exactly why that happened. The team added userid as a label to a latency histogram. Each unique userid creates a new time series. With thousands of users, the series count exploded to 250K per hour, consuming 24 GB of memory on a 16 GB pod, triggering the OOM killer. The fix was to remove the high cardinality label. Instead of per-user metrics, they aggregated by endpoint and used recording rules for percentiles. They also set a series limit to prevent future explosions. The key change was dropping the userid label. This is the exact mistake from the incident. Adding userid as a label creates a new time series for every unique user. With thousands of users, the series count explodes and Prometheus runs out of memory. Summaries compute quantiles on the client side and cannot be aggregated across instances. In a multi-replica deployment, use histograms instead, which can be aggregated with histogram quantile. A network policy that denies all ingress without allowing Prometheus's namespace will silently block scraping. Always include an ingress rule that allows traffic from the Prometheus namespace. The ScrapeConfig (CRD) is only available in Prometheus Operator v0, 65.0 and later. If you are running an older version, you must use ServiceMonitor or PodMonitor instead. Check your operator version with kubectl get Prometheus Operator all namespaces, or by inspecting the operator pod logs. The article warns about high cardinality labels, but does not show how to drop them at scrape time. Use metric relabel configs to drop unwanted labels before they enter the TSDB. This is a critical production pattern to prevent OOM kills. The article mentions network policies as a silent killer, but does not provide a concrete diagnostic step. To verify, exec into the Prometheus pod and use wget or curl to reach the target's metrics endpoint directly. If it fails, check network policy rules and ensure Prometheus's namespace is allowed. To debug scraping issues, check the Prometheus targets page to see which targets are up or down. Monitor the active series count with Prometheus TSDB head series. Use the top query to find high cardinality metrics, and always test network connectivity from the Prometheus pod. Let's run through some common interview questions. What causes Prometheus OOM-kill in K8s? High cardinality labels explode time series, consuming memory. How does Prometheus discover targets in K8s? Via Kubernetes SD configs querying the API server. Why use histogram over summary? Histograms can be aggregated across instances. Summaries cannot. And a few frequently asked questions. What is a high cardinality label? A label with many unique values like userid or requested. How to prevent OOM-kill? Avoid unbounded labels, set series limits, use recording rules. What is the difference between ServiceMonitor and ScrapeConfig? ServiceMonitor is high-level for services. ScrapeConfig gives full Prometheus config control. To summarize, avoid high cardinality labels like userid. Use bounded label sets. Prefer histograms for latency. Set series limits and monitor your series count. Use recording rules to optimize query performance. Ready to go deeper? Up next, Kubernetes architecture explained, then Kubernetes network policies. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.